Okay, on problem number 3, and again, my recommendation is to definitely look for a GCF. And I'd look for a numerical one and then certainly variable. What do I see over here? I definitely see a factor of 3, a numerical factor of 3 between those 3 terms. What else do I see? I do not see any x factors common to all 3 terms, but I do see a common factor of y squared. What are you left off with? Well, on the first term, you'd be left off with x squared. We will check this, by the way. On the second term, you got a 3, and let's see, you're going to need an x. Right. In the last term, what do you get? You're going to need a 5. What do you mean by checking it is just simply multiplying it out. What do you get? 3x squared y squared minus 9xy squared plus 15y squared. Is that what the original statement is? Let's take a look at it. I'm looking at these two over. I'm not saying that's the answer, by the way. 3x squared y squared minus 9xy squared. Yeah, it looks great. So I'm going to say this is my answer. It's what's known as the GCF factorization of the problem. And let's look at the k. You might be surprised that the key might be a little bit different. 3y squared, no, it's the same. X squared minus 3x plus 5. I realize some students at this point saying, why don't you try to factor the quadratic? You could. So let me put this down for you. If you were to try this though, a good try would be x and x. And the only other thing you could do thinking about integer numbers would be 5 and 1. I hope you realize at this stage here, you're never going to get the minus 3x. So I'm going to say factoring quadratic at this stage is not going to be helpful. All right, let me erase some of the extraneous stuff over that I don't need anymore. I don't need my check written over there. But I do want to go to the answer key. And again, I want to confirm that we're getting what we expected to get in the answer. Thank you.